Good evening, all. Welcome to today's live discussion session for the NPTEL course Water Supply Engineering. I hope I'm audible to everyone. I'm Reshma R, a PMRF research scholar from Hydraulics and Water Resource Engineering Division, Department of Civil Engineering, IIT Madras. I'll be handling the live discussion session for NPTEL course Water Supply Engineering every Tuesdays from 7 to 9 pm. So I shall share my screen now. Please let me know whether it is visible to you.
Yes, ma'am.
Okay, thank you. So, uh, in this live discussion session, we'll be basically discussing about the theoretical as well as problematic questions that was provided for the assignment last year in the NPTEL course. So, this year the course have started. Almost 2 weeks have been completed. So, you might have been acquainted with the kind of assignments you are getting, the kind of questions you have to solve in the assignments. So, the questions that we discuss here in this live discussion sessions will be the questions that were given in the last year. That is, previous year questions will be discussed. Also, I'll be happy to clear your doubts regarding the topics covered during the week. Okay. So I shall put it into screen share mode, slideshow mode. Okay. So this is the first question for today. The total amount of water used by a person in a day is approximately option A less than 50 liters, option B 100 to 200 liters, option C 400 to 500 liters, option D greater than 500 liters. So you can type in your answers in the chat box. Okay, let me open the chat box in my mobile. Yeah. Okay, I got two answers. Yes, please everyone should participate in the discussion. Then only we can make it a live session. So, yes, I'm getting mixed answers now. All right. So, the majority of the answer is I request everyone to mute your mic. Otherwise, disturbances will be there in the call. I'm sorry. If you have a doubt, you can please raise your hands and then unmute yourself and then ask the doubt. No issues. But in between, while I'm explaining or discussing, if the mic is on, it will be a disturbance for others. All right. So we'll continue. Okay. So a few answers have been option B 100 to 200 liters, and also I have got two answers as less than 50 liters. So the question is total amount of water used by a person in a day. It's the total amount that is used by a person. So let's see what is the correct answer. Yes, correct answer is option B 100 to 200 liters. So the domestic requirement of water typically varies between 100 to 200 liters per person per day, or liters per capita per day is the unit that we use. So for Indian cities, if it is an urban area, we consider it as 200 LPCD, and for rural areas, we consider the domestic requirement per day as 135. So the answer is 100 to 200 liters, so that it will cover both rural as well as urban area. I hope that is clear. Okay, so moving on to the second question. Sorry, I'll just explain the other demands as well. When we are talking about the domestic demand, we have certain other demands as well, like industrial demand, public demand, losses and theft, etc. Also, this depends upon the type of Indian town we are talking about. All right. Okay, so first we'll look into what is rate of demand. So in the question, we were asked what is the total amount used by a person in a day. So the quantity of water required by an average human to fulfill all his daily needs is termed as rate of demand. That is, the term rate of demand represents the amount of water used up by a person to fulfill all his daily needs, so that it will cover right from the domestic needs, from like cooking food, then sanitation purposes, washing clothes, then gardening, everything is included in that. So it is the quantity of water required to fulfill all his daily needs, that is the rate of demand. And this will vary from town to town. We are concerned about Indian conditions. In Indian conditions itself, we have with full flushing system and without full flushing system. Without full flushing system represents rural areas where we have or where we had Indian water closets. Every one of you know that the amount of water required for a flushing system will be much more than that required for a non-flushing system. So all these criterias were actually formed years back. So it's like now almost everywhere it is full flushing system, but according to the criteria or classification, it's like without full flushing system and with full flushing system. So in the case of an average Indian town without full flushing system, the domestic demand is taken as 135 lpcd. Lpcd is liter per capita per day, that is liter per person per day. So 135 lpcd is the domestic demand, 70 lpcd is the industrial demand, 10 lpcd is the public demand, and 55 lpcd is losses and theft. So now what are these losses and you all might have understood what is industrial demand. Of course, yes, the water requirement in an industry for the production of something. Public demand, it is the requirement of water to meet the public requirements. For example, public buildings, it can be a public building like hospital. But now what is losses and theft? There can be leakages happening when we are supplying water from its source to the consumer. There can be different kind of losses happening. It can be some hydraulic losses happening or physical losses happening, that is leakage kind of. Now what is theft? So theft of water, what does it mean? We all know that at our consumer end, there will be one water meter. So, if that water meter is faulty, what will happen? It will not show the exact value of water used. That means, and if we are not reporting to the authorities, it's a kind of theft because we are not letting the authorities know that we use this much amount of water. Or sometimes there can be chances of occurrings where additional unauthorized connections are being taken in between the pipelines. Tappings are made in between the pipelines. So, all these come under theft. I hope it is clear to you. So, the same thing for an average Indian town with full flushing system. As I mentioned earlier, only the domestic demand varies. The domestic demand increases to 200 lpcd. All the other values doesn't vary because it is just the flushing system that is we are concerned about. Okay, so I hope it's clear to you. Moving on to the next question. Question number 2. Conductivity in water is due to the presence of option A, dissolved salts, option B, volatile organic compounds, Option C, suspended solids. Option D, water molecules. What is the reason for conductivity in water? Yes, I'm getting answers. Um, yes, so the correct option, all of you have typed correct answer. Yes, it is option A, dissolved salts. So we all know that water molecules as such are poor conductor of electricity. The presence of dissolved salts leads to ionic compounds in water, thus adding to conductivity. All right, we'll move on to the next question. Which of the following appears an adequate range for residual water pressure in household water taps? Which of the following appears an adequate range for residual water pressure in household water taps? Option A, 3 to 6 meter. Option B, 12 to 24 meter. Option C, 50 to 60 meter. Option D, 70 to 90 meter. Which is the adequate range for residual water pressure in household water taps? So, uh, I've got three answers in the no two answers in the chat box. Okay, many are coming up. Okay, so all of you have selected option A, 3 to 6 meters. Let's see which is the correct answer. Sorry to say, option B, 12 to 24 meter is the correct answer. So we'll see why. So, what is residual water pressure? They're asking about the adequate range of residual water pressure. So, what is residual water pressure? It is the pressure remaining in a water supply while water is flowing. So, it is not the static pressure, it's the pressure under the condition when water is flowing. So, the minimum residual water pressure that is required in the household water taps is 7 meters. So since our first option is only till 6 meter, we can't consider that. If it was 3 to 7 meter, we could have chosen that, but it is only till 3 to 6 meter and the minimum requirement is 7 meters. So of the given values, the best option will be 12 to 24 meter, which is the requirement of residual water pressure in household water taps. I hope that is clear. Moving on to the next question. Question number 4. NRW, typically used for assigning system efficiency of water utilities, stands for option A, non recyclable water, option B, non rechargeable water, option C, non recurring water, option D, non revenue water. So, among these options, what does actually NRW stands for? Okay, I'm getting answers. Okay, I'll wait for a minute. Let everyone type in. Okay, so every one of you have uh, selected the correct answer. That is option B, non revenue water. So, what is non revenue water? It indicates the quantity or percentage of water that is not generating any revenue for the utility. That is not giving any profit or amount of like amount in the form of cash for the utility. It includes water loss and non-chargeable supplies. So earlier when we were talking about like previous problem or previous question, we were discussing what is water loss. So obviously water loss means it is that part of water is getting lost while we are transporting our like water from the source to the consumer end. So since it is lost in between, it is not generating any revenue. So it comes under non-revenue water. And the next one is non-chargeable supplies. Also, as we told earlier, this water loss can be physical or apparent. What is physical loss? It is leakage. Any kind of leakages happening can be considered as physical loss, whereas all the theft can be considered as apparent loss. All right. So the next category in the non-revenue water is non-chargeable supplies. Non-chargeable supply is the supply of water where we are not charging. We are actually supplying water. It is not a kind of loss, but we are not able to charge for it. For example, in the case of firefighting, we need a huge amount of water, but we are not authorized to charge for the amount of water that we use for firefighting. So that kind of uh, things comes under non-chargeable supplies. Okay. Okay. So question number 5, that is what all right. So question number 5, that is waterborne diseases are typically attributed to the pollution due to dash present in water. Option A, suspended solids. Option B, hardness. Option C, salinity. Option D, pathogens. Which of the following causes waterborne diseases? Which of the following causes waterborne diseases? Okay, I'm getting answers. I'm getting mixed answers. Um, no, all of them have typed the same. Okay, all right. Hmm. So let's give a minute to everyone to type in the answers and then we shall look which is the correct answer. So I hope I'm not going too fast or too slow. Okay. So let's see what is the correct answer. Correct answer is option B, as all of you have said. It's pathogens. So now what is pathogens? Pathogens are microorganisms that causes diseases. And waterborne diseases are caused due to the presence of these pathogens in water. All right. So we'll move on to the next question. Question number 6. Largest river basin in India is option A, Narmada Basin, option B, Ganga Basin, option C, Kaveri Basin, option D, Godavari Basin. Which is the largest river basin in India? Which is the largest river basin in India? Is it Narmada Basin, Ganga Basin, Kaveri Basin, or Godavari Basin? I think. Okay. Okay, I was just not able to see the chat messages in the phone. Sorry. Okay, so yes, the correct option is option B, Ganga Basin. So we'll see what is the catchment area of each of these basins. So the Ganga Basin is the largest river basin in India, having a total catchment area of around 8 lakh 61,452 square kilometers. The second largest is the Godavari Basin with 3 lakh 12,812 square kilometers. Then Narmada Basin. Narmada Basin is the fifth largest with a catchment area of 98,796 square kilometers. And Narmada River is the largest west flowing river of our country. And last, Kaveri has a total catchment area of 81,155 square kilometer. So, Ganga Basin, option B is the correct answer. It is the largest river basin in India. All right, we'll move on to the next question. Question number 7. Which of these are predominantly groundwater contaminants? Option A, arsenic and fluoride. Option B, dissolved oxygen. Option C, suspended and colloidal solids. Option D, pathogens. Which of these are predominantly groundwater contaminants? Which of these are predominantly groundwater contaminants? So earlier we saw surface water contaminant. Now it's about groundwater contaminant. Okay, I'm getting mixed answers. Let's wait for a minute. All right. So the correct answer is option A, arsenic and fluoride. So the major contaminant in the case of groundwater is arsenic and fluoride. All right. So we'll move on to the next question. Question 8. The current central ministry looking after water resources related activities and policies in India is option A, Ministry of Drinking Water and Sanitation. Option Option A, Ministry of Water Resources, River Development and Ganga Rejuvenation. Option B, Ministry of Drinking Water and Sanitation. Option C, Ministry of Jal Shakti. Option D, Ministry of Environment, Forest and Climate Change. So this is kind of a general knowledge question. Which is the current central ministry that is looking after water resources related activities and policies in India? So, four ministries are given in the options. Which among them handles water resources related activities? I'm getting mixed answers again. Okay. So I think almost everyone, no, only a few have typed in the answer. Okay, let's give a minute for others. Okay, Let's see. The correct answer is option C, Ministry of Jal Shakti. So, Ministry of Jal Shakti actually was formed in May 2019 by merging two ministries, that is Ministry of Water Resources, River Development and Ganga Rejuvenation, as well as Ministry of Drinking Water and Sanitation. They were merged together as Ministry of Jal Shakti to look after the water resources related activities. So, first three options are covered. That is, first two were joined together to form Ministry of Jal Shakti. So now we have one more ministry, that is Ministry of Environment, Forest and Climate Change. This is actually a nodal agency in the administrative structure of the central government for planning, promotion, coordination, and overseeing the implementation of India's environmental and forestry policies and programs. So it's more related to environment, forest, and climate change. Okay. So I don't know whether the late joinees had gone in between and then rejoining or joining late. So I would like to request everyone to join on time, that is 7 o'clock itself, so that you won't miss any questions in between. I think now we have already covered 8 questions. So please try to join exactly at 7 o'clock itself so that you won't miss any questions. Okay. All right. So we'll move on to the next question. That is question number 9. Jal Jeevan Mission aims at option A, rainwater harvesting and beneficial uses. Option B, river development and Ganga rejuvenation. Option C, providing functional water tap to every household. Option D, all of the above. So, what is the primary aim of Jal Jeevan Mission? Is it regarding rainwater harvesting, or river development and Ganga rejuvenation, or about functional water tap supply to every household, or is it about all these things? So, what does Jal Jeevan Mission aim at? Okay, I'm getting answers. Mixed up answers are there. Okay, so some are confused about C and D. Okay, so the correct option is option C, providing functional water tap to every household. That is the primary aim of Jal Jeevan Mission. So, Jal Jeevan Mission was announced by Prime Minister, and it aims to provide functional taps for water supply to all of the households by 2024. That is the aim of Jal Jeevan Mission, the proposed aim of Jal Jeevan Mission. So for rainwater harvesting, which was option A, we have another mission, that is Jal Shakti Abhiyan. Uh, can't see your screen, Dhananjay, and have put a message that my screen is not visible. Is it the same for everyone or is it just for Dhananjay? Can someone else let me know?
No, we can see.
Okay, okay, thank you, thank you. Mm, it's working for us, but okay. So for some people, it's not working, I guess. Maybe it's a network problem at your end because other people are able to see. Okay, okay, or it may be a fluctuation of network here. Okay. Anyway, sorry for that. So we'll move on. So rainwater harvesting. For rainwater harvesting, we have Jal Shakti Abhiyan, another mission by our central government. That is Jal Shakti Abhiyan, Catch the Rain. That is the mission name with the theme Catch the Rain Where It Falls When It Falls. That is particularly for rainwater harvesting. So we'll move on to the next question, that is question number 10. I hope all the questions till now are clear to everyone. So we'll move on to the next question. In water treatment, reverse osmosis is typically used for the removal of. So all of these questions are actually from zeroth assignment, which is maybe this time also that assignment is there, week zero assignment, which is before the start of the course itself, just to um, know the depth of the knowledge that you have. All these will be individually taught in the later on sessions, in the later on weeks. So this is just to know the awareness what you have, like the level of awareness you have. So in water treatment, reverse osmosis is typically used for the removal of option A, dissolved salts, option B, suspended solids, option C, turbidity, option D, dissolved gases. So for which type of treatment we use reverse osmosis, or for the removal of what we use reverse osmosis in water treatment? Okay, so some are telling that option A is the answer, and some have option B as the answer. Okay. Okay, so let's see what is the correct answer. Correct answer is option A, dissolved salts. So, reverse osmosis is typical desalination method used for the removal of dissolved salts. So, for the removal of turbidity, we have flocculation or coagulation. For the removal of suspended solids, we use sedimentation or water filters. For the removal of dissolved gases, we use the method of heating or boiling. So, dissolved salts are removed by reverse osmosis, turbidity with the help of flocculation and coagulation, suspended solids with the help of sedimentation or water filters, and dissolved gases by heating or boiling. All right. So, moving on to the next question. Total dissolved solids TDS in drinking water should ideally be option A 0, option B less than 20 milligram per liter, option C 100 to 500 milligram per liter, option D greater than 2000 milligram per liter. So, which is the correct option? Total dissolved solids in drinking water. The permissible limit for total dissolved solids in drinking water. Is it 0, less than 20, 100 to 500, or greater than 2000 milligram per liter? Which is the ideal value? Okay. So we'll see the correct answer. It's option C, 100 to 500 milligram per liter. Yes, we have got many answers as option C itself. Yes. So it is 100 to 500 milligram per liter. So 0 or very low TDS value is not considered as ideal for drinking water because they won't even have the useful minerals and nutrients. If TDS is 0 means it will be the water will not even have the required minerals or useful minerals or nutrients. It will be devoid of all the dissolved solids. So that is not recommended for drinking water. So these recommendations are actually made by Indian standard. There is code for each they like each specification is mentioned in typical Indian standard codes. So it mentions that zero or very low TDS is not recommended for drinking water. Now, coming to high TDS water, it is also not suitable because this will contain very high level of dissolved salts, including unwanted minerals. So that is also not accepted. So typically 100 to 500 milligram per liter is regarded good for drinking water. All right. So moving on to the next question. A
Uh,
brackish,
excuse me, ma'am. So
yes,
in the but in the question, specific code name is not mentioned, like whether it is IS code or any other code, it is not mentioned. For drinking purpose, usually we are following IS 10500, that
yes.
code, but nothing is mentioned in the question.
No, this actually it's just mentioned as ideally what should be the value. It's not mentioned about codes. That's correct. But these permissible limits have been set by the codes. So there is no other reference to which we can refer to. That is what I was meaning.
Okay, okay, ma'am.
Yeah. So even if we are giving for giving samples from our household for testing, the laboratories will be depending upon the Indian standard codes for um, categorizing the type of water we have. So that was what I was meaning. Okay, so I hope that is clear. Now we'll move on to the next question. Oh, sorry. Yeah, so that's a problem, a simple problem. A brackish water stream containing 5000 milligram per liter salt concentration meets a freshwater stream having 200 milligram per liter salt concentration. The discharges, that is the flow rates, of brackish stream and freshwater stream is 2 meter cube per second and 22 meter cube per second respectively. Assuming complete mixing and no decay or consumption of salt in river, the salt concentration in downstream of the meeting point of the two streams would be. So there are two streams. One is a brackish water stream, another one is a brackish water stream, and another one is a another one is a fresh water stream. So one is brackish water, another one is fresh water. They are meeting at a point. We are asked to determine the salt concentration downstream to this meeting point. So they are given discharge values for both brackish stream and freshwater stream. That is the flow rate for brackish stream is 2 meter cube per second or 2 cubic, and for freshwater stream is 22 meter cube per second. Also they are given the salt concentration for brackish water stream as well as freshwater stream. It's simple mathematics and logic that we have to apply. Also, we are assuming that there is no loss of salt or water happening here. There is complete mixing. So, whatever is meeting is then flowing together to the downstream, and we are measuring that value at the downstream end. So, we have option A 300 milligram per liter, option B 600 milligram per liter, option C 1200 milligram per liter. Option D 2400 milligram per liter. Okay. So we'll wait for a minute so that everyone can solve the problem. Okay, so we'll see what is the correct answer. Does anyone need more time to solve, or shall I move on to the answer? Okay, so we'll move on to the answer. The correct answer is option B. As most of you have answered, it is 600 milligram per liter. So we'll see how to solve this. So the total salt inflow in the freshwater river is 22 into 200. That is 200 milligram per liter is the salt concentration in the brackish stream, and the freshwater stream has a discharge of 22 meter cube per second. So the total salt inflow will be 4400 meter cube per second milligram per liter. I'm not converting the meter cube to liter here because at the end it will get cancelled. So it's an unnecessary process doing here. That's why I have written it as such. Now the total salt inflow in the brackish water stream is 2 into 5000 in a similar way. So we'll get it as 10,000 meter cube per second milligram per liter. So the total inflow of salt, that is both these freshwater stream and brackish water stream have now joined. So the total salt inflow will be 10,000 plus 4,400, which comes to 14,400 meter cube per second milligram per liter. That is the total inflow of salt. Now, the total flow in the river downstream is the sum of the discharges of brackish water stream and the freshwater stream, which is 22 plus 2, that is 24 meter cube per second. So now we need to know the salt concentration in this flow. So we have total salt and total flow. So the salt concentration will be 14,400, that is total salt inflow, divided by total flow, that is 24 meter cube per second, which comes to 600 milligrams per liter. Hope the problem is clear to everyone. Alright, moving on to the next question. 1 milliliter of a solution containing 10,000 milligram per liter alum is added in a jar containing 2-liter distilled water. The alum concentration in the jar would approximately be option A 2 milligram per liter, option B 5 milligram per liter, option C 10 milligram per liter, option D 50 milligram per liter. So there is 2 liters of distilled water in a jar. I'm adding 1 milliliter of a solution to that, and this 1 milliliter solution contains 10,000 milligram per liter alum. So after the addition of the solution to this jar, what will be the alum concentration in that jar? So we'll give time for everyone to solve the problem, and then we'll see the answer. Okay, got three answers. Okay, so we'll see what is the correct option. I think I have got four answers now. Okay. Um, okay. So we'll see what is the correct answer. Correct answer is option B, 5 milligram per liter. So it's mentioned for 10,000 milligram per liter solution. That is the actual alum concentration in the solution we took. It was 10,000 milligram per liter, and we have added 1 ml of the solution to 2 liters. So we know that 1 liter is approximately 10,000 milligram. That is 10,000 milligram per liter solution. That means if we convert this liters into milliliters, it will be 1000 ml and 10,000 milligram. Right. So in 1 ml, it will be 10 milligrams because we are adding 1 ml of the solution. So 1 ml solution or 10 milligram alum in 2 liters of distilled water means 10 milligram alum per 2 liters. That is 10 by 2 milligram per liters. So it is 5 milligram per liter alum concentration. Right. Okay. So moving on to the 14th question. Which of the following models represents a first order decay of a pollutant having concentration C at time t? Consider K as constant. So, which is the equation that represents first order decay equation? First order decay. Option A, dC by dt is equal to 0. Option B, dC by dt is equal to K. Option C, dC by dt is equal to Kc. Option D, dC by dt is equal to K by C. So, C is the concentration at time t, K is a constant, dk constant. So, which of the equations represents first order decay of pollutant? Okay, I'm getting multiple answers. Okay, so the correct answer is option C. dC by dt is equal to Kc. So the first order decay model is dC by dt is equal to Kc. Okay, so moving on to the 15th question. This is more of a general mathematic question. Since it was there in the previous year zeroth assignment, I have added that also. So 2 points 6 comma p and 2 comma q lie on a straight line having a slope of 0.75. The value of p minus q is. So we have 2 points with the coordinates 6p and 2q. 6 comma p and 2 comma q. It's given that they lie on a straight line which has a slope of 0.75. If it is so, what is the value of p minus q? Option A 3, option B 4, option C 6, option D 8. So, slope of the line is given, 2 points on the line is given. We are asked to determine the value of P minus Q. So, let's give everyone time to solve this. Okay, so I've got many answers. Hmm. Okay, so let's see what is the correct answer. Hmm. Correct answer is option A 3. So we know that since 6 comma p and 2 comma q lie on a straight line with a slope 0.75, we know how to determine slope of a line with the points x1 y1 and x2 y2, right? That is y2 minus or y1 minus y2 by x1 minus x2. So it is p minus q by 6 minus 2 is the slope, the value of which is given in the question as 0.75. So rearranging the terms, we have p minus q will be equal to 0.75 into 6 minus 2. So 6 minus 2 is 4. So it will be 0.75 into 4, which is equal to 3. So the correct answer is option A 3. Okay. So moving on to the next question. Knowledge and awareness to consumers about water sources, availability and demand, financials and governance, etc. can option A enhance people's trust in water utility, option B motivate people for judicious use of water, option C increase stakeholders' engagement in water governance, option D, all of the above. So, the knowledge and awareness to consumers about the source of water, availability of water, demand, financial, governance, everything can aid in which of these following? Okay. So, I have got all the answers as option B. Yes, that's the correct answer. Option B, that is all of the above. So, knowledge and awareness to consumers about the details of water services, right from the source of supply, the total amount available, the demand that is there in the society. All these can motivate people for judicious use of water without the wastage, without unnecessary wastage of water. They will be motivated for judicious use. Also, it will increase stakeholders' participation, as well as it enhance people's trust in water utility, because everything is transparent, right from governance to the source of supply. Everything is, if it is transparent, it will increase people's trust as well. Okay, so moving on to the next question, question number 17. As per international norms, a country with a water availability of less than 1000 meter cube per year per person is termed as option A, water scarce country; option B, water stressed country; option C, water shortage country; option D, all of the above. So if a country has water availability less than 1000 meter cube per year per person, whether is it water scarce, water stressed, water shortage, or is it all of these? What will we term such a country with water availability less than 1000 meter cube per year per person? Okay, so we'll see what is the answer. Correct answer is option A, water scarce country. So according to international norms, per capita water availability less than 1700 meter cube per year is termed as water stressed country, whereas if it goes below 1000 meter cube per year per person, we'll term it as water scarce country. So, what is water stress and water scarcity? Two terms we have come across. So, water stress actually occurs when the demand for water exceeds the available amount during a certain period, or when poor quality restricts its use. That is, whenever the demand for water exceeds the available amount of useful water. Useful water, in the sense, it should be useful in terms of quantity as well as quality. So, if demand exceeds this amount, that situation is termed as water stress. All right. So, what is water scarcity? It is the lack of fresh water resources to meet the standard water demand. It's not the water demand during a particular time period, it's the generalized water demand that is considered when we talk about water scarcity. So, it is the lack of fresh water resources to meet the standard water demand. All right. So we'll move on to the next question. Question 18. The highest percentage of freshwater resources exist in the form of option A, rivers and streams; option B, lakes; option C, ice caps and glaciers; option D, groundwater. So, where does the highest percentage of freshwater resources exist? Or in which form does the highest percentage of freshwater resources exist? Is it in the form of rivers or streams, or in the form of lakes or ice caps and glaciers, or is it in the form of groundwater? Okay, so we'll see what is the answer. Correct answer is, as you all have typed in, it is option C, ice caps and glaciers. So we'll see the distribution of Earth's water. So this is um, from part of study conducted by US Geological Survey, Water Science School. So as per the study, of the total global water, as you see in this first um, diagram, of the total global water, 96.5 percentage is in oceans. So obviously it is not fresh water. Then other saline water consists around 0.9 percentage, and fresh water is only 2.5 percentage of total global water. Only 2.5 percentage of total global water is existing as fresh water. Majority of water is in oceans, salt water. Okay. Now, of these 2.5 percentage, a major portion, that is 68.7 percentage, exist in the form of glaciers and ice caps. Remaining 30.1 percentage exist in the form of groundwater, and another 1.2 percentage as surface and other freshwater. So it's obvious that the major portion of the freshwater exists in the form of glaciers and ice caps. Now again, this small 1.2 percentage of the whole freshwater which exists in surface and other freshwater is the readily available form. Still, within that also, a good percentage is existing as ground ice and permafrost, which is not easily recoverable. Another 20.9 percentage is what we see in the lakes. Of the remaining portions, almost 3 percentage is in the atmosphere as moisture. Another 3.8 percentage exists as soil moisture, 2.6 percentage as swamp and marshes, a very small amount 0.49 percentage is existing in the rivers, and 0.26 percentage is within the living beings including human beings. Okay, so this is the distribution of total global water. Okay, so we'll move on to the next question. The term water scarcity denotes option A, physical shortage of water availability, option B, lack of funds to access the available water, option C, lack of infrastructure to ensure water supply, option D, any of the above. So, what does the term water scarcity denotes? Okay, I'm getting answers. Okay, Viresh has raised a hand. Yes, Viresh. Please unmute yourself and ask the doubt. Hello, Viresh. I think I'm spelling your name correct.
Yes, ma'am. Correct. It is correct. It is correct.
Okay. So please ask your
Good
doubt.
evening, ma'am. First of all.
Yeah, okay, good evening.
So first of all, what is when the what scarcity means there is a something deficient. I mean, not available in so much quantity. What
Yeah,
I get it.
yeah.
But here the what when I see the options here,
Hmm. Yes.
Physical strategy. Okay, okay. It's a first option is correct for my point of view.
Okay. Okay.
Uh, I I don't think that the option B, C, how it relevant to the
Okay.
what I have.
Okay. Okay. I understand your concern. So let's see what is the
Okay.
correct answer and then let's discuss about that. Okay.
Okay.
All right. So the correct answer is option D, that is any of the above. So as Viresh had asked, we will see how it is possible for that option to be the correct answer. So the global water shortage or water scarcity can be actually of two types. One is physical water scarcity, that is there is physical limitation in access to the water available, that is maybe because of the quality or the non availability due to the form in which it exists. All these can be the factors for physical water scarcity. Now another type of water scarcity is actually economic water scarcity. This is where water is there, but people or the consumers do not have the necessary monetary, they do not have the necessary income to utilize the adequate water source, or it may be the lack of infrastructure to access the water. That is quantity wise and quality wise we have plenty of water in this case, that is in the case of economic water scarcity, but we are unable to extract the same. It may be because of the monetary issues, financial issues, or it may be because of the technical issues. Technical issues in the sense, maybe the authorities do not, or authorities or the consumers do not have required infrastructure to extract or access that particular water. So that is why we are saying it is any of the above in this case answer. Okay, so it's big global water shortage is basically of two types. It's both physical as well as economic. All right. I hope it is clear. Okay. Mm, we'll move on to the next question. Uh, okay. So the largest river basin in India in terms of utilizable groundwater resources is. Earlier we saw the largest river basin. Okay, I think there is some confusion in the question. I think it should be the state with largest utilizable groundwater resources. Okay, I shall correct that before uploading it in the um, folder. So, okay, so we'll just read it as the state with largest utilizable groundwater resources. Because if I skip back to the normal slide mode, the answer will be visible in the next slide. So I don't want to do that now. I'll correct the thing before uploading. So I'll just correct it and read it as the state with largest utilizable groundwater resources is option A Kerala, option B Punjab, option C Karnataka, option D Uttar Pradesh. Which of these states have the largest amount of utilizable groundwater resources? Which state do you think have the largest amount of utilizable groundwater resources? So, we are talking about utilizable groundwater resources. Mm, there was a table in week 1 lecture notes where professor have included the state-wise utilizable groundwater resource amount. So this question is from that table. So, which state do you think have the largest utilizable groundwater resources? Um Okay, so we'll see. It's option B, Uttar Pradesh. It has around 77.19 billion cubic meter annual replenishable groundwater resources. So the answer is option D actually. I think almost everyone had answered option A, Kerala. But I think for Kerala, it is the surface water that is there. So, in the case of replenishable groundwater resource or utilizable groundwater resources, it's Uttar Pradesh with 77.19 billion cubic meter. All right. So, we'll move on to the next question. Which of the following statements is true concerning the population vis-a-vis land and water availability in India? Statement 1. India has more than 17% of the world's population. Statement 2. Only 2.4% of the world's renewable water resource is available in India. Statement 3. India holds around 4% of world's land area. So which of these statements are true? Option A. Only statement 1 is true. Option B. Both 1 and 2 are true. Option C. Both 2 and 3 are true. Option D. All statements are true. So one statement is regarding the India's population with respect to world's population. Second statement is regarding the availability of renewable water resource in India with relative to world, and the third is about land area. So which of these statements are true? Okay, I'm getting answers. Hmm, okay, only few of them have answered. Let's just wait so that everyone can type in. Because I see only five answers here. Yeah. Okay. So let's see what is the correct answer. So the correct option is option A. Only statement 1 is true. As most of you have answered, it is option A. So it's correct that India has more than 17% of the world's population, but it has only around 4% of world's renewable water resources and 2.4% of land area. Okay, so this is the actual statistics. More than 17% of world's population with 4% of world's renewable water resource and 2.4% of world's land area. Okay. So we have question number 22 here. The largest water consuming sector in high income, that is developed countries, is which of the which of the below options is the largest water consuming sector? Option A domestic, option B industries, option C environment, option D agriculture. The question is with regard to developed or high income countries. Developed or high income countries, which is the largest water consuming sector. Okay, so many of you have answered option B and a few option A. Okay. So let's see. The correct answer is option B, industries. So, in case of competing water use worldwide for high income countries as well as low and middle income countries, a pie chart is given. So, in the case of worldwide use, agricultural use comprise around 70 percentage. Then comes industrial and then the domestic. The trend is similar in the case of low and middle income countries as well. In the case of high income countries, industrial use is more when compared to domestic and agricultural use. Around 59 percentage water use is actually initiated by the industries, whereas only 30 percentage is with the agricultural sector and 11 percentage with the domestic. Okay, so we'll move on to the next question. The illness primarily caused by unclean water and living conditions is option A, diarrhea, option B, cholera, option C, typhoid, option D, all of the above. So earlier in one of the question we had mentioned the that the presence of pathogens or disease causing microorganisms in water may lead to waterborne diseases. So here we are asked which all are the waterborne diseases caused due to unclean water. So we have three options and all of the above as well. Which of these are primarily caused by unclean water and living conditions? Okay, so I am getting majority of the answers as option D. Okay, let's see. Yes, correct answer is option B. Diarrhea, typhoid, and cholera. All of these are caused by unclean water as well as living conditions. All right. So we'll move on to the next question. Which Indian states are most affected by arsenic pollution in water? So earlier in one question we had mentioned the primary polluting agent in case of groundwater is arsenic and fluoride. Hope everyone remembers. So this question is which Indian state is most affected by arsenic pollution? Option A, Assam and West Bengal. Option B, Bihar and Uttar Pradesh. Option C, Assam and Karnataka. Option D, West Bengal and Punjab. Which Indian states are most affected by arsenic pollution in water? I have got few answers. Okay, let's see. The correct answer is option A, Assam and West Bengal. The arsenic affected inhabitants are highest in West Bengal, followed by Assam and then Bihar. So the answer is Assam and West Bengal. Okay, so now we have a match the following question. Match the following government agencies in India with the responsibility entrusted to them. So here's a table at the bottom. Uh, on one column we have A, B, C, three government agencies of India, and in the other column we have some duties. So we have to match the government agencies with their duties. So A, Central Pollution Control Board. B. Central Public Health and Environmental Engineering Organization, and C. Central Water Commission are the three government agencies given. And the duties are: one is surface water management, second one setting up norms, guidelines, and manuals for water supply, sanitation, and sewage disposal, and the third one is water quality monitoring. So, which of the agencies are entrusted with these duties? Option A, A3, B2, C1. Option B, A1, B2, C3. Option C, A2, B1, C3. And option D, A1, B3, C2. Which is the correct option? Uh, okay, I'm getting similar answers from everyone. That is option A. Okay, let's see. Yes, the correct answer is option A. That is Central Pollution Control Board, or CPCB in short, is entrusted with the water quality monitoring. Central Water Commission, or CWC, is in charge for data collection and making policies related to surface water management. And Central Public Health and Environmental Engineering Organization, CPHEEO, is entrusted with setting up norms, guidelines, and manuals for water supply, sanitation, and sewage disposal. We have what is called as CPHEEO manuals, which are to be followed while designing the sewage disposal units, then surface and sewer, um, water transportation systems and all. So they have set up norms and manuals for that. All right. So hope it's clear till this question. Moving on to the next question. In a typical urban setup, urban water services include: option A, water supply and distribution; option B, wastewater collection and treatment; option C, stormwater collection and disposal; option D, all of the above. So, urban water services. What all functions does it serve? Is it only about water supply and distribution? Or does it include wastewater collection as well? Or does it include the stormwater collection also? So, what is the urban water services all about in a typical urban water setup? Okay. I think almost everyone have answered. Hmm. Yeah. So yes, it's option. No, I think few of them have to answer yet. Uh, Let me see. Okay. Almost everyone have answered except a few. I think only two have to answer. Okay. So the correct answer is all of the above. That is, a centralized system will be there in urban water services. It will be a centralized system which handles right from the supply of water from source to consumers, collection of the wastewater generated from the consumer's end, whether it be domestic, industrial, or public. Treatment of this collected wastewater. Apart from this, it will also handle the storm water, that is the rainwater. So, all of these comes under the centralized system of urban water services. Okay, so we have the next question. The final component of an urban water supply system is option A, water treatment, option B, distribution network, option C, reservoirs, option D, water intake. Which, uh, please mute yourself. I think I'm muting whoever was unmuted, maybe by mistake. I'm muting them just for sake of others. Sorry. Okay. So, coming back to our question, the final component of an urban water supply system is, which among them is the final component? Okay. Few of them have to answer, so let's wait for them. Uh, okay. So we'll see what is the correct answer. Yes, as every one of you have said, it is option B, distribution network. So, a typical urban water supply system will have water intake, water treatment, as well as water distribution. So, the components of water supply engineering is basically the source of water, then the intake works, then conveyance, treatment, and distribution. So, first of all, to decide the source, to fix the source, we need to estimate the quantity of water required, which depends upon the rate of demand, which we discussed earlier, and the population of the area. Depending on that, we'll fix up a source which meets our requirements quality wise as well as quantity wise. It should meet the standards prescribed by IS Indian standards as well as CPHEEO, all the standards it should meet with, and then we'll fix up the source. Then we have the intake works. So we'll just see a flowchart diagram. So for suppose we have lake as the source. This is the intake structure. Intake structure is the structure that helps to extract water from the selected source. It may be merely pipes, maybe pump with pipe system. So it depends upon the type of source you selected. So we have some sort of intake structure. Then you have the treatment, because the water you collect from the source cannot be supplied as such. It may contain unwanted minerals, it may contain pathogens, it may contain unwanted components. So we need to ensure that it is fit for drinking and other uses. So it needs to be passed through several treatment steps, which you will be learning in the subsequent weeks. So some sort of preliminary treatment and secondary treatment will be there to remove, as we discussed earlier, the dissolved gases, dissolved solids, suspended solids, pathogens. All these will be removed through these steps. and then we'll supply it to the storage system if the end consumer point is very far from the source. Then we can provide for a temporary storage nearby, or else in the treatment plant itself we can provide a storage system, and either with the help of gravity flow or by with the help of pumping, depending upon the elevation to which or height to which it is to be supplied, we'll provide it to the consumers through the distribution system. So the last part is basically the distribution system starting from the source. Okay, hope that is clear to you. So moving on to the next question. Which of the following is not an intermediate link in a typical urban water cycle? Option A, rainwater harvesting. Option B, reuse of treated wastewater as reclaimed water. Option C, non usable disposal of wastewater. Option D, collection and use of stormwater runoff. So, which is not there in urban water cycle, which is not a link in urban water cycle? Okay, I'm getting answers as option C and option B. Okay. All right. So the correct answer is option C, non usable disposal of wastewater. So the intermediate links in a in an urban water cycle, includes reuse of treated water as reclaimed water, reuse of storm water runoff, as well as rainwater harvesting. But the option C, that is non usable disposal of wastewater, is actually not a part of urban water cycle. Okay, thus it's actually the non usable disposal of wastewater would take away the disposed water from the urban water cycle. It's not circulating anymore in the urban water cycle. So it's not an intermediate link there. Hope that is clear. Moving on to the next question. Question 29. The earliest stage of integrated urban water management is option A, strategic prioritization of tasks. Option B, setting up a monitoring framework. Option C, formulation of integration action plan and targets. Option D, initiation and assessment of existing services and infrastructure. Which among these is the earliest stage of integrated urban water management? Okay, so I'm getting mixed answers. A is there, C is there, D is there. Okay, only B is left. All right. So we'll see what is the correct answer. The correct answer is option D. Process initiation and assessment of existing services and infrastructure. So, for integrated urban water management, the first step is initiation and assessment of existing service and infrastructure. First, we need to know what is there already. Further and beyond, only we need to develop. So, the first step is assessment of the existing structures, existing infrastructure, existing services. The next step is visioning and formulation of integration action plan and targets. Third step is strategic prioritization of task. So first we will understand the existing strength. Then we'll formulate the action plans, targets, aims and all, we'll set it up. Then we'll prioritize the task. We will arrange them in order of priority. Then these identified tasks are which are prioritized is implemented in order. So in order to ensure that the process is going on smoothly, we need to set up a monitoring framework as well. Unless monitored, none of the system will work perfect. So the needs or there exists a need for setting up a monitoring framework. Also, stakeholder, I'm sorry, I think my screen was lost in between. So, till what point were you able to see my screen? Hello, am I audible?
Yes, you are audible now.
Okay, so till what point you were able to see my screen?
Up to second point, visioning and formulation.
Okay, okay, sorry for that. So, now it is visible, right?
Yes, it is visible now.
Okay, okay. So, in the case of integrated urban water management, so first step we will understand the strength of existing services and infrastructure. After that, we will formulate action plans, targets, aims, which all are to be implemented. So, once we identify the task, next step is to prioritize them, to prioritize according to their importance. Once that is done, we'll implement these tasks one by one and then we'll slowly achieve each of the targets. So, for that, for the smooth functioning, we need to set up a monitoring framework to monitor the process overall. Also, stakeholder engagement and consultation is to be sought at all stages. That is a mandatory thing. All right. So, this is what happens in an integrated urban water management. So, if we see this flow chart, each stages are clearly mentioned right from stage 1, that is process initiation and preliminary assessment of existing level of integration, to stage 4, that is monitoring framework for project sustainability. So overall this is what is happening within a urban water cycle. From source, we are taking it up. After treatment, we are distributing. And then in between, we have collection of storm water as well. And then once we distribute it, we need to collect the wastewater that is generated at the consumer end. We have to treat this wastewater. If reusable, we have to reuse. If rechargeable, we have to recharge, or we have to dispose it off. Once disposed, that water is no longer a part of urban water cycle. Okay, the remaining water will be continuing to flow in this urban water cycle itself. All right. So with that, I think the questions have come to an end. So if any one of you have doubts regarding today's live discussion session, or any other doubts regarding water supply engineering classes during this week one, you may please raise your hands and then you can ask your doubts, or you can type it in the chat box also. Okay, I'll come back. I'll stop the screen share. Yeah. So, if any one of you have doubts, we have 15 more minutes left.
Last class and this class had lot of repetition. Like last set of questions were already asked in last class.
Yeah,
So
actually, it is like we are two TAs, that is teaching assistants, working under PMRF, so helping out in this water supply course. So the aim is like whoever are not able to attend during Saturday sessions can attend for Tuesday sessions, or whoever are comfortable with Saturday sessions can attend that, and others can attend Tuesday session. So maybe timings may be convenient, like it will be different for each of you, right? So because some of you may be working, some of you may be having different other works. So just for your convenience, we are two separate teaching assistants handling the sessions. So the
okay.
questions discussed will be basically the same. I
Hmm.
think maybe the other TA had discussed only week one assignments. That's why only a part you felt repetitive. I had
Ah,
included zeroth and first assignment.
understood, madam. Thank
Yeah.
you so much for
Okay.
clarifying.
Okay. Thank you. So any other doubts?
Yes, ma'am.
Yes.
Uh, One question I found:
Hmm.
annual average per capita water demand of a city,
Hmm.
expressed in liter per capita per day, is uh, one option is per head water consumption in a day averaged over a year, and another option is average of water consumed by a person in a year.
What was the first option? Can you please repeat?
Uh, the question is annual average per capita water demand of a city expressed in liter per capita per day
Okay.
is
Okay.
per head water consumption in a day averaged over a year, or average of water consumed by a person in a year.
Uh, it's annual average per capita, right?
Yes, yes.
It's annual average per capita means it will be, um, if I'm correct, it should be the average of the usage. No, no, no. Okay, okay. First option is average of the usage per year, right?
First one is per head water consumed in a day averaged over a year. And second
Okay.
one is average of water consumed by a person in a year.
Okay.
Actually, two other options were there, but one answer, I think,
I
out
think
of these two,
option
that is
A, I think option A will be the correct answer.
yes.
Yeah.
Per head water consumption in a day averaged
Averaged
over a
over a
year.
year. Yeah, because it's like
Yes.
We are concerned about the daily usage, and then we have to take the annual average. If it's a case of, actually, from the definition you can understand. The thing is, just take the definition, or the that statement, go from left to right of that statement, you will get the word answer, like word by word, meaning of that. uh,
Okay.
do you get my point? Like, if it is annual average per capita, split it from the end and come to the beginning. That will be the
Okay.
order of calculation. Okay. Any other doubts? uh, okay, we have 10 more minutes. If anyone else have doubts, you may please unmute and ask.
Yes, another question.
Yeah.
Can I ask?
Yeah, yeah, sure, sure.
Two statements are given.
uh,
First statement is a better estimate of design capacity of the water distribution system for a town is using the peak hourly demand.
okay.
And the second statement is the estimate of peak hourly demand considers both daily and hourly variations in water demand.
Okay.
So, and it is given that statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true, third one, both statements are false, fourth one, both statements are true.
Okay. So as far as I remember, statement one should be false, because design should not be based on the peak hourly demand. Uh, and option two is peak hourly demand is, what is the option two?
Considers
Huh.
peak hourly demand considers both daily and hourly variations in water demand.
No, it just considers the hourly what? No, peak hourly demand. Um, Peak hourly demand. I'm not sure whether it considers the daily thing. So, okay, the options, can you repeat? Statement one is true, two, that.
One is true,
Hmm,
two is false.
okay.
Second one is false, two is true.
Oh,
Third one, both are false. Fourth one, both are true.
okay, so I think it is either B or C. Um, I need to check it, because I'm not
Okay,
sure
ma'am.
about
Okay.
that peak hourly demand and the connection with hourly and daily. I'm a bit confused.
Okay, ma'am. Next class, can it be clarified?
Yeah,
This
yeah, sure,
question.
sure, sure, sure. Okay. Any other
Okay, thank
questions?
you.
Okay. Anyone else have questions? You may please ask, or else we can conclude the session for today, and we'll meet during the next live discussion session on next Tuesday, 7 to 9 p.m. Okay. So if you have no doubts, you can leave the session and we'll meet during the next session. Okay, thank you, Lakshmanan. Thank you. Thank you, sir. Thank what about what about assignment? Mustafa Hussain, I didn't get the question actually. Is it about the current assignment questions? Can
Yes, ma'am.
no, actually, current assignment questions we are not supposed to discuss over the sessions because that is being evaluated currently as part of your like grading. So
Okay.
this sessions are actually to help you to solve the current year assignment questions.
Yes,
So,
ma'am.
okay, so we'll be discussing only the previous year assignment questions and we'll try to include similar questions as that of current year assignment questions.
Okay.
Okay,
Okay, ma'am. Thank you.
okay, thank you.